Welcome to Mrs. Sou's Math World. Today we are going to start integration. Integration is the opposite of differentiation. So let's see how it works. So I would like to write down the things of question 1 in the spaces provided in the notes. Alright? Okay, so if I dx squared, you will get 2x. If I differentiate x squared minus 2, it is also equal to 2x. And similarly, if I differentiate x squared plus 6, it is also equal to 2x, right? So that means if I change this to x squared plus any constant number, and you will also get 2x. Okay, so here is the answer key for question 1 to 3. I still haven't talked about the things of primitive function. Okay, but let's have a look on the answer first. So all these are equals to x. All right. So let's talk about the math term here. Whenever you got a derivative, okay, you see that the capital letter 1 is the primitive function of the small one. Okay. Now why we use the capital letter? Because it reverses the opposite step. Before that, we learned differentiation. We go forward in this way. But right now, we are going to do integration. Then it is the reverse progress. Okay? So this step is actually called integration. We integrate. Before that, we differentiate. I insert this right on D. Okay? So primitive means original of it. Okay? So in this case, x squared plus c will be the primitive function of 2x. But of course, you can let different sorts of examples. So that's why for question 3, you can say x squared minus 2. That means these functions can also be primitive function. Of course, you can let other letters if you like. For example, you can say x squared minus 10 is also fine. But if you say it is 2x squared, it's not okay. Because you can only do changes in the constant term. But you cannot make any change on the variables. So this time the variable is x. Okay. Then we need to use a notation to handle it. Okay. So this one is on the next page on the textbook. So you may go to page 6.6 to refer to this one, the formula. Okay. So the indefinite integral of it. Okay. With respect to x, if it is the primitive function, then we can write it down as f of x with respect to x. Then we have the integral. But remember, we can have any value of c. So this one is called arbitrary constant. Arbitrary means it can be any value of c. So this one called primitive function. And then dx represents, we are going to integrate with respect to x. That means x is variable. Other things remains constant. Okay, so this is the formula for us. Then we will go to the next page to discuss the property of that. These are the formula in page 6.7. So when you take the notes here, you may skip this, but you need to know, of course, k has to be constant. For this one, n cannot be -1 for the power because it goes to k past c. Okay, and then you also need k cannot be 0. So let me modify it. Okay, so this is a way to take notes. So let's take the empty space to check why we get such formula. Okay, let's use the primitive function here to do the checking. So let's do it one by one. The first one, you get k, if you differentiate, you get constant term. And for part B, if I differentiate this one, and then you will have n plus 1 on the lower part, and then n plus 1 take it out, and then the power will be -1. That means it's equals to x to the power n. So this is the thing that you can think about it. When you differentiate the n power n minus 1, n plus 1, then it goes to power n. So you need to think about what happened before. So log x is a little bit special because for the value of x, it cannot be negative. And this is called absolute sign to let the negative value will not be happen. For example, if I put -3 for the absolute sign, it becomes 3. If I put a positive value, it is still positive. Anyway, it is a minor stuff. Okay, so I differentiate the log x, and I will get 1 over x. So these are the things for the polynomial and also for 1 over x. Then it goes to D and E for the exponential one. For the exponential one, this one is quite obvious, right? Because when I differentiate e to the power x, it becomes itself. And for e, if I differentiate 1 over k e to the power kx, then remember we get the upper part differentiate, we will get k times e to the power kx, and then cancel out the things, we will get e to the power kx. So this is the way of how to remember them. Because when you are doing the exercise, it is very important for you to think of the primitive function once you look at the question. So this basic skill is very important. The highlighted part are the primitive function of the inequal. So please spend more time in training your basic differentiation and also basic integration. We shall go to the example in the next video.